So in this video we will study the effect of change in temperature according to Le-Chatelier principle. So consider the heat as a part of reactant or product. So we have to consider the heat as a part of reactant or product. For an example, in case of endothermic, where heat is considered as a part of reactant, right? Endothermic is represented also like if we have positive delta H, right? So positive delta H means endothermic, and negative or we can also say that if delta H value is more than 0, so this is a endothermic process and heat is part of reactant, so heat is also considered as a reactant. And in case of exothermic reaction where delta H is negative, or we can say that delta H is less than 0, so in that case heat is considered as a part of product, another product. So we use this principle to understand effect of heat or effect of change in temperature for the reaction. So let's take one example. So for an example, this is a reaction we have already studied in previous video. This is carbon dioxide gas and water is combined reactants, and they are forming glucose and oxygen, and the heat is, so here you can see the delta H is positive, it means there is no sign, it means this is a positive, and delta is positive means it is an endothermic reaction, right? So means heat is considered as a part of reaction. So this heat is this side, like that. This is the reactant and this is the reactant part, and these two are the product part. So what will happen? An increase in temperature or addition of heat. So increase in temperature or addition of heat, basically we are adding more reactant, right? So heat is considered as a reactant, so basically we have more reactant, and if we have more reactant, will result in a shift in the equilibrium toward the right side, or product will form more, because this heat is considered as a reactant. So basically if we are increasing the reactant, we are disturbing the equilibrium, and to negligible to remove the effect of the heat and temperature, this equilibrium will shift toward the right side and product will form more where less heat generate. Decrease in temperature or removal of the heat will result in shift of the equilibrium toward the left side, right? So if we remove the reactant, basically if we remove the reactant or decrease the temperature, photosynthesis will not work, right? Or reaction will slow down, or whatever the product is formed, it will consume and it will form more reactant to balance the equilibrium. So equilibrium will shift toward the left side. So this is the effect of the one example of the effect of temperature. Another example is here. I have another example in this reaction where delta H is says more than 0, means endothermic. This is another example of endothermic. Heat is a part of the reactant, and this is a cobalt salt which is in the water, and chloride ions and cobalt chloride and water. So this is the pink and this is the blue. So if we are increasing the heat, if we put this in the hot water, right, this is hot water. So if we increase the heat, means we are increasing the reactant. If we have more reactant, the equilibrium will shift toward the right side and product will form more. That is why we have blue color here, right. If we will decrease the temperature, if we will put in the ice water, if we place this reaction tube into the ice water, so what will happen, basically we are removing the heat, and if we are removing the heat, basically we are removing the reactant and equilibrium will shift toward the right side and reactant will form more. That is why we have pink color here. So these are the some examples for the temperature effect and heat effect on the equilibrium according to Chatelier principle. So let's see the another example, another effect for that is called the change in pressure and volume. So let's see how this will be affecting. Decrease in the volume, so volume decreases, or increase in pressure increases. The reaction shift to the side of the small number of moles. Reaction shift toward the small number of moles, right. So for an example, if we have a big balloon, right, big balloon where the gas is filled, and if we squeeze this gas into a smaller volume balloon, then number of moles will also be less, right. So equilibrium will shift toward the small number of moles, and also here you can see pressure is less, here pressure is more, pressure basically increases, and volume is V, and here volume basically decreases, and because pressure and volume, they are inversely proportional. So if we will increase the pressure, volume will decreases, and equilibrium will shift toward the side where the less number of moles are there. So you can also consider that if we have a bigger room of the class where 100 student can sit, and if we move those 100 student into the smaller class where 10 times less space or 10 times less seats are there, so only small number of student can sit, right. So that is why we can use that analogy to here also. And another condition is increase in the volume. So suppose we have a small volume and we are going to big volume. Increase in the volume increases, and if we are increasing volume, pressure will decrease, or decrease in the pressure. The reaction shift toward the larger number of moles, right. Larger number of moles will form, equilibrium will shift toward the larger number of moles. So let's see one example to understand this effect of pressure and volume. So here in one example it says that there are red ball which represent the 2A gas, and this kind of green or yellow ball which represent the product B. So here we can rewrite like this one, 2A is in the equilibrium with the B, right. So here 2 moles are there on the reactant side, and here is 1 mole, means a small number is this side and larger number of moles on this side, right. So what will happen? So here you can see this reaction is in this container, where red ball representing the 2A and the green ball representing the product B. If we count total 1 2 3 4 5 6 7 8 9 10, so there are 10 red ball equal to A, 10 red ball are A, and 1 2 3 4 5 6 7 1 2 3 4 5 6 7 and 7 green balls representing the B. Now if we will increase the volume is increased and pressure is decreased, so we move from smaller container to big container. What will happen? So here my equilibrium will shift toward the larger number of moles. That is why we have more red balls, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, so 16 red and 1 2 3 4 5 6 and 6 green. So my equilibrium shift toward the larger number of moles which represent the reactant side. So basically if you will increase the volume or decrease the pressure, the effect on this equilibrium will shift toward the reactant side. And if we move from further smaller container, basically here we are reducing the volume but pressure got increased. In that situation you can see only one red ball is there, and if we count total number of the green balls, 1 2 3 4 5 6 7 8 9 10 11 12 13, so 13 green balls are there. It means if we are in this situation, if we are decreasing the volume and increasing the pressure, equilibrium is shifting toward the smaller number of volumes, which is product side. So effect of pressure and volume is depend on the stoichiometry of the reaction, how many moles on the reactant side and how many moles on the product side, that we have to consider, then we can answer the question. Let's take one more example. According to Chatelier principle, change in the pressure and volume affect only the position of the equilibrium if the number of moles on each sides of the reaction vary. That is why I was saying you have to consider how many moles on the reactant side and how many moles on the product side. If so, here for this reaction you can see this is in the liquid form, pure liquid, which we do not include in the equilibrium, and this is pure solid, this is not taking part in the equilibrium, and here we have 6 mole reactant carbon dioxide gas and 6 mole oxygen product. So both have the same number of moles, right. So no effect of pressure or volume, whether you change the volume or not, whether you change the pressure or not, there will be no difference, would not have any effect, no effect on the pressure and effect if the number of moles on both sides same. So this was the another scenario, and let's see one more thing, that this reaction PCl5 PCl3 Cl2 gas, delta H is positive, means this is a endothermic reaction. Endothermic reaction means this is a part of reactant. So heat is a part of reactant. This is my reactant also, right? And how many moles on this side? 1 mole. And total mole on this side, product side, is 1 mole, 1 mole, total 2 mole. So we have larger number of moles on the product side and lesser number of moles on this side. So Cl2 is removed. Cl2 is removed. If you remove the Cl2, reactant is removed, product is removed, it means reaction will shift toward the right side. All the reactant will try to consume to make more Cl2. Temperature is decreased. Temperature is a reactant here because delta H is positive. So if you are decreasing the temperature, basically you are removing the reactant. It means equilibrium will shift toward the left side, where, so basically I will say that heat is a part of reactant, and if you are removing the heat, basically reaction will chlorine and PCl3 will make more PCl5. The volume of reaction is increased. Volume is increased. If we have more volume, we can accommodate larger number of moles. It means equilibrium will shift toward the product side. PCl3 gas is added. More PCl3 is added. It means we added more product. If we added more product, basically what will happen? Equilibrium will shift toward the reactant side, left side. The pressure of the system is increased. So pressure is increased. Pressure is increased means volume decreases. If volume decreases, so equilibrium will shift toward the smaller number of moles, means reactant side. What would be the only combination of the temperature and pressure change indicate increases or decreases that would ensure the increase in production of Cl2? So if we have to make more Cl2 gas, right, more chlorine gas, we need to make more chlorine gas. So what will happen? So we need to increase temperature. Increase temperature means give more heat, and decrease the pressure. So these are the two conditions that can help in Cl2 production. And last effect on the Chatelier principle about the addition of catalyst. So catalyst is a substance that changes the speed of the chemical reaction without itself undergoing permanent chemical changes process, right? So addition of catalyst do not change the equilibrium, only the rate at which equilibrium is achieved. So basically we can understand this effect of catalyst by this slide, that if this red line shows uncatalyzed reaction, where is no catalyst is here. If you will add catalyst in the reaction, basically it decreases the activation energy and it increases the rate of the reaction, right? So here this shows that it was the uncatalyzed reaction, and here is the catalyzed reaction. So basically addition of catalyst do not affect, no effect on equilibrium, no effect on equilibrium. The only it increases the rate of the reaction, that's it, speed up. So this was the Chatelier principle and their effect with the pressure and volume and catalyst.